You are given nums and queries. Each query is a triple, left L, right R, and a cap val. Process queries in order. For each query, each index from L through R may be decreased by any amount from 0 up to val, chosen independently at each index. The answer is the smallest non-negative k such that after applying only the first k queries, every entry of nums is 0. If that cannot happen, the answer is -1. Example 1, nums is 2, 0, 2. 3 queries, 0, 2, 1, then the same again, then 1, 1, 3. First query covers all 3 indices with cap 1. Subtract 1 at index 0 and 1 at index 2, the middle stays 0. That gives 1, 0, 1. Second query does the same again, giving all zeros. We never need the third query, so the minimum k is 2. Second example, nums 4, 3, 2, 1, with queries 1, 3, 2 then 0, 2, 1. Even using the caps aggressively, you cannot reach all zeros, so the answer is -1. Feasibility is monotone in k. If the first k queries can already zero nums, you can treat any extra queries as doing nothing, so a larger k never becomes harder. That is why we can search for the smallest k efficiently. Brute force means trying k in order, start at 0, then 1, then 2, then 3, and keep counting up until you are sure. A much faster way is binary search on k. You try a middle value, learn whether the real answer is smaller or larger, and repeat until the smallest k is clear. To test one candidate k, reuse the difference array idea. For each of the first k capped ranges, add val at index L and subtract val just after R, then one prefix sweep totals how much decrease is available at every index. Compare that sweep to nums column by column. If some cell is short, you need more queries, so push the search toward larger k, otherwise you can try smaller k, repeat until you lock in the minimum k. Binary search on k, low starts at 0, high at 4, mid is 2, we test whether the first 2 queries can zero the array. Build a difference array for those 2 ranges, then one prefix sweep gives the most decrease available at each index. Index 0 is short, so k equals 2 is not enough. Move low past mid to 3. Try 3 prefix queries. Caps meet nums everywhere, so 3 works. Remember 3 as best and pull high below mid. Low and high cross, so the answer is 3. If no k ever worked we would return -1. Time is big O of n plus m times log m in the worst case. Each binary search step tests 1k by packing the first k queries into a diff and scanning nums once. Extra space is big O of n for the diff array. Feasible tests 1 candidate k. Build a diff array of length n plus 1, all zeros. Loop t from 0 through k minus 1. Unpack left, right, and val from queries at t. Add val at index L in the diff. Subtract val at index R plus 1 in the diff. Set running sum run to 0. Loop I from 0 through n minus 1. Add diff at I into run. If run is still less than nums at I, return false. Otherwise return true. Min k binary searches how many prefix queries are needed. Read n as nums length and m as queries length. Set low to 0, high to m, answer to -1. While low is at most high. Set mid to the floor of low plus high, divided by 2. If feasible at mid, we can try a smaller k. Remember mid as the best answer so far. Move high down to mid -1. Otherwise we need more queries. Set low to mid +1. Return the stored answer.